All right, so these are your limiting reactant notes, as well as percent yield. So limiting reactants. So whenever we're thinking about this is going to be more challenging conceptually to understand at first, but I promise if you're patient, we will work through it and do lots and lots of examples together. All right, so we're just taking notes at this point. So when you think about limiting reactants, you're thinking about the thing that limits how much product you can make. All right, so for example, if I have 8 car bodies and 48 tires, I know that each car body is going to need 4 tires, right? So if I do 8 times 4, I get 32. All right, so I am only going to use 32 tires, so I make my 8 cars, and I have 16 extra tires here after I've made my 8 car bodies. So in this situation, we know that the car bodies are going to be what limits us, right? If I had another car body, I have extra tires to make more cars. So this would be our limiting reactant, or the thing at the beginning that limits how much we can make. Okay, so this is if you wrote it as a formula. Car body, 1 car body plus 4 tires yields a car. Okay, so here's a real chemical example. So if I'm looking at 8 carbon atoms plus 24 hydrogen molecules. So remember, each of these is a hydrogen molecule. So hydrogen is H2, so there are 2 H's per molecule. That would yield 8 methane molecules, right? Each methane has 1 C and 4 H's. So I've used all of my carbons, but I didn't use all of my hydrogen. So if I do 8 times 4 again, right, that's 32 hydrogen atoms, which if I divide that by 2, it gives me 16 hydrogen molecules. So I should have 8 hydrogen molecules left. Okay. So again, this is just looking at what is limiting how much product we can make. Okay, so if I'm looking at iron and sulfur, trying to make iron sulfide, ideally every single one of these would be paired up. But usually what ends up happening is you have one of the elements or compounds in excess. So the one that is not in excess, which in this case would be iron, we would call our limiting reactant, or that's what limits how much we can make. So the limiting reactant is always used up completely in a reaction. That means we don't have any left over. And it determines the amount of product that we can make. So an excess reactant is always added to ensure that the other reactant is completely used up. All right, so anytime you're looking at a chemical equation, you're always going to have a limiting reactant and at least one excess reactant. If it's a situation where you have 3 reactants, 3 things on the reactant side, then only one of those would be limiting and 2 of them would be excess. Okay, and the excess is usually you pick the one that's cheaper and easier to recycle, right? Because you're going to have some at the end in the product because it did not get all used up. So if I'm looking at aluminum plus chlorine gas, which would give me aluminum chloride, here's my balanced chemical equation. So, okay, I start off with 100 grams of aluminum, 100 grams of chlorine, and I want to know how much aluminum chloride I can make. This is where our limiting reactant comes into the problem. But in this case, I don't know. No one has told me what the limiting reactant is. All right, so we're going to use stoichiometry in order to find that out. Okay, so we're going to start with aluminum. And if you look at your graphic organizer, in this case, we're going to go from aluminum to aluminum chloride. We're starting with mass of aluminum, and we're trying to get to mass of aluminum chloride. All right, so first you go to moles of aluminum, and then moles of aluminum chloride, and then mass. Right? So whenever we're starting in our table, you always start with what you're given, which in this case is 100 grams of aluminum. And then the next part of our table, we use the molar mass of aluminum to convert to moles. All right, so that's this step right here. This right here. And then we use our mole to mole ratio, which we're going to get from our balanced chemical equation, right? 2 to 2. All right, so we've canceled out moles of aluminum. Now we're in moles of aluminum chloride. So we're at this point of our graphic organizer here. And finally, we're going to use the molar mass of aluminum chloride to convert back to grams. So when we solve it, we get 494 grams of aluminum chloride could be produced if we start with 100 grams of aluminum. All right, so we still don't know. We know that this is how much we would make theoretically, but we also don't know if aluminum chloride or aluminum is our limiting reactant. So the next step would be to look at how much product would be made if we start with 100 grams of chlorine gas. All right, so we're going to do the same thing where we're going from chlorine to aluminum chloride, going from mass to mass, and we do that through mass to moles, moles to moles, and then moles to mass again. All right, so we're going to start with 100 grams of chlorine. We use our molar mass of chlorine, or Cl2, to convert to moles. Then we're going to use our mole to mole ratio, which we get from our balanced equation, which is 3 moles of chlorine to 2 moles of aluminum chloride. And that way we cancel out our moles of chlorine, and now we're in moles of aluminum chloride. And then our last step is to use the molar mass of aluminum chloride again, right, to convert to grams of aluminum chloride, which would give me 125 grams of aluminum chloride. All right, so when we're looking at this, so okay, if I start with 100 grams of this, and assuming this is the limiting reactant, we would get 125 grams of aluminum chloride. Whereas if we start with 100 grams of this, it would get 494. So this tells me that Cl2, or chlorine gas, is my limiting reactant, because when I put 100 grams of this and 100 grams of this to react, this is the one that limits how much I'm going to make. All right, so that's the way, a long way to figure out how many or what the limiting reactant is. So this is method 1, where you write a balanced chemical equation. For each reactant, we calculate the amount of product formed. And the smaller answer indicates the limiting reactant and the amount of product that it should make. All right, method 2. So we begin by writing a correctly balanced chemical equation. We write down all quantitative values under the equation. So the quantitative just means the numbers. So I'm writing down if I'm starting with 100 grams or I'm starting with 2 moles or whatever, I'm writing those numbers under the equation. Then you convert all reactants to units of moles, right? So this is before you look at reactants to products. And then we divide by the coefficient in front of each reactant. And then the smallest value is the limiting reactant. So this way is actually a little bit shorter than method 1. And we will work some of these problems together so that you can see how to work through those. All right, so these are your limiting reactant notes. Make sure you have them written down and come show them to